Problem 13 on your review asks you to list the first seven counting numbers that are multiples of 12. Since we're talking about counting numbers, that would not include 0. 0 is a multiple of 12, but it's not a counting number. So the first multiple of 12 that is a counting number would be 1 12, which is 12. Then 2 12s, 24. 3 12s, 4 12s, 5 12s, 6 12s, and 7 12s. Those are the first 7 positive multiples of 12. Which of these numbers have a total number of factors? Total number of factors, so we want all of the factors, not just the prime factors. So we're going to use UT model. A total number of factors that is also a multiple of 12. Well, the factors of 12 are 1 and 12, 2 and 6, and 3 and 4. That is a total number of factors, 6 factors. 6 is not a multiple of 12. 6 is a factor of 12. So that one doesn't work. 24 has the factors 1, 24, 2, 12, 3, 8, 4, 6, for a total number of factors of 8. Also not a multiple of 12. 48, 1 48, 2 24, 3 16, 4 12, 5 doesn't work, 6 times 8 is 48. That's a total of 10 factors, also not a multiple of 12. I'm going to do the rest down below because I don't think I'm going to fit them. 60, 1 multiplied by 60, 2 multiplied by 30, 3 multiplied by 20, 4 15s is 60, 5 12s is 60, 6 10s is 60, 7 doesn't work, 8 does not work, 9 doesn't work, that's it. So 2, 4, 6, 8, 10, 12. 12 factors, and 12 is a multiple of 12, so 60 is one of the answers. Careful when you're counting your factors. Don't forget that if we have a perfect square in here somewhere, I won't count the square root twice. That would not count. This has nothing to do with this problem, but just so we're clear on this. 25 is 1 times 25 and 5 times 5. There are not 4 factors here. There are 3 factors. 1, 5, and 25. That's separate from this problem. Okay. 72. It's 1 72. It's 2 36s. It's 3 24s. It's 4 18s. It's not 5 anything. It's 6 12s. It's not 7 anything. 8 works because I could double my 4 and half my 18. So 8 9s. That's 2, 4, 6, 8, 10. Also 12 factors. So 72 is also one of the multiples of 12 that has a total number of factors that is also a multiple of 12. And lastly, 84. Let's check 84. It's 1 84. It's 2 42s. It's 3 28s. 60 and 24, yes. It's 4 21s. It's not 5 of anything, but it is 6 14s. It is 7 12s. 12 times 7 is 84, right? 8 doesn't work because I need to double my 4 and I cannot have my 21 and get a whole number factor, so 8 doesn't work. 9 doesn't work because 8 plus 4 is 12, and 12 is not a multiple of 9. 10 clearly doesn't work. 11 doesn't work, and 12 we have. So there are 2, 4, 6, 8, 10, 12 factors, total number of factors for 84 as well. So the 3 answers to the second part of the problem are 60, 72, and 84. Problem 14. Use prime factorization to simplify this fraction. So I need the prime factors of 420 and the prime factors of 504. 420 is 2 210s. 210 is 2 multiplied by 105. I can't use any more 2's, but 105 is divisible by 3 because 1 plus 0 plus 5 is 6, and 6 is a multiple of 3. It's 3 35s, and 35 is 5 7s. 504 is 2 252s. 252 is 2 126s. 126 is 2 63s. 63 is 3 multiplied by 21. And 21 is 3 multiplied by 7. So by substituting this fraction for the expanded prime factorization of 420 and 504, I can then cancel out common factors, which is the same as factoring out ones. So 420's expanded prime factorization is 2 multiplied by 2, multiplied by 3, multiplied by 5, multiplied by 7. And 504's expanded prime factorization is 2 of 2 of 2 of 3 of 3 of 7. 7 sevenths is 1 whole. I don't have to show those ones, but it's kind of nice to show them in case you end up canceling out all of the factors in the numerator. Remind you still have 1 up here. 2 halves is 1 whole. 2 halves is 1 whole. 3/3 is another whole. I'm left with a 5 up here, no 5s down here, and a 2 and a 3 down here, and no 2 or 2s or 3s up in my numerator that I haven't already canceled. And so the final simplified fraction would be 5 over the product of 2 and 3, which is 6, so 5/6. Problem number 15. Find a composite number between 50 and 60 whose prime factors have a sum of 11. So 50 is 2 25s, and 25 is 5 of 5. We're looking for a composite. This is clearly composite since it has factors other than 1 in itself. But do those prime factors have a sum of 11? We don't usually add factors, but it's what the question's calling for. So the sum of 2 and 5 and 5 is 12, and so 50 doesn't work. 51 looks prime at first, but then you realize 5 plus 1 is 6, which is a multiple of 3, so it's 3 17s. And 3 plus 17 is 20, so that's not a sum of 11. 52 is clearly composite since it's even, it's 2 26s. 26 is 2 13s. And 2 plus 2 plus 13 is 17, not 11. 53 seems prime. It's clearly not divisible by 2. The sum of the digits is 8, so it's not divisible by 3. I don't need to check 4 since it's not divisible by 2. It doesn't end in a 5 or a 0, so it's not divisible by 5. If it's not divisible by 2, it's not divisible by even numbers, so I don't need to check 6 or 8. It's not divisible by 7 because I know 7 sevens is 49. So I'm not finding any factors other than 1 in itself. So it's not composite, and so it can't be our answer. 54 is 2 27s. 27 is 3 9s, and 9 is 3 3s. 2 plus 3 plus 3 plus 3 is 11, and so 54 is a composite number between 50 and 60 whose prime factors have a sum of 11. Okay, the final problem. The Mayans used more than one calendar system. One calendar had 365 days. Another calendar had 260 days. If both calendars began on the same day, and how many days would they next begin on the same day? So the calendars would repeat 260 days for one, 365 days for the other, year after year, until after some multiple number of years, they would begin on the same day. We want the next time that would happen, so that would be a common multiple, but the least common multiple of 365 and 260. So let's use our Venn diagram model. 365 It's not divisible by 2. 3 plus 6 is 9, plus 5 is 14. It's not divisible by 3. It's not divisible by 4. It's divisible by 5. Certainly it ends in a 5. 5 multiplied by 70 would be 350. And multiplied by 73 would be 365. 73 is also prime, so that factor tree is done. 260 is divisible by 2. It's two 130s. 130 is two 65s. 65 is not divisible by 3 because 6 plus 5 is 11, and that's not a multiple of 3. It is divisible by 5. It's 5 13s. So when I make the Venn diagram for 365 and 260, there's a common prime factor of 5 in the intersection. And then we need a 73 here and two 2s and a 13 here. The least common multiple now would be 73 times 5 times 2 times 2 times 13, but it's a lot easier to just do, let's see, it's probably easier to just do 260 multiplied by 73. Because I could do 73 multiplied by 26 and then just shift the place value up one place to multiply by 10. 3 6s is 18, carry the 1, 7 6s is 42, plus 1 is 43. Now I'm multiplying by 10, so I put a 0 here. 3 2s is 6, 7 2s is 14. So I get 1898. And then multiply by 10 to account for this. So 18,980 days would be the how many days it would take for them to occur, for both calendars to occur on the same day again. Now, at the bottom, I'm reminding you that this same idea of LCM can be used to find a common denominator, because if I want to compare these fractions, the lowest common denominator is the LCM. And so if I want to convert these into the common denominator, which we now know would be 18,980, I need to multiply 260 by 73 to get that number. Your Venn diagram model will tell you that 260 multiplied by 73 gives you this LCM. So I multiply by 73 73rds to turn this denominator into 18,980ths. And 27 multiplied by 73. Actually, it'd be pretty easy just to use this, right? It's one more 73 than this, because this is 26 73s. So 1898 plus 73, which I really didn't need to do traditional algorithm here, because if I add 2 more, I have 1900. So I have 71 more than that, so 1971. The 38 365ths can be converted into 18,980ths by multiplying by 2 times 2 times 13, because 365 multiplied by 2 times 2 times 13, which is 4 times 13 is 52, will give you that LCM. And so 38 multiplied by 52, I kind of want to do 38 multiplied by 100 because that's easy. It's 3,800. Half of that, 1,900, would be 50 38s, and 2 more 38s is 76, so 1976. Look, you're welcome to do the traditional algorithm for multiplication if you like, but every once in a while I like to just show you ways you can do these things mentally. And it's nice to be able to do it that way. This is 50 38s. This is 2 more 38s. So that's 52 38s. It's really fast once you practice that method. And you see how close these are. These are extremely close, these two fractions. However, 1976 is slightly larger than 1971. And so 27 260ths is less than 38 365ths. Okay, that completes the review. Thank you for studying so hard. I know you're going to do great on your test. I'll see you tomorrow.